All right, couple of words, and David already introduced me briefly. So I'm working as a senior developer advocate for AI and machine learning at AWS. Also, as mentioned, I'm currently writing a book together with my co-author Chris Reckley on data science on AWS, so feel free to check that out. We'll cover a lot of the content in that book as well, and we're running a couple of workshops on the content. So if you're interested in learning more, then you're going to see in the next 25 minutes, feel free to reach out. All right, yeah, before joining AWS, maybe a couple of words. I worked many years at Cisco here in Germany in the data center space. I joined MapR afterwards and worked there for 3 years, so also having a big data background. And the last couple of years really focusing a lot on AI and machine learning. And yeah, I'm super excited and thrilled about the topic, as probably all of us in this conference today. All right, so quick agenda walkthrough. I introduce and start quickly with why are we thinking of doing machine learning with containers, and in particular running it on Kubernetes. Then I'll introduce you to Kubeflow and also in particular to the Kubeflow pipelines project. We're gonna see a demo. I guess we're all curious to see how this actually works. So I'm gonna show you how you can get started creating a Kubeflow pipeline. And then as an extra bonus, I'll talk a little bit about how you can scale the machine learning Kubernetes even further with integrating with cloud managed services on the example of Amazon SageMaker. And we'll also see a demo on that part. All right, so let's jump right into the topic. So why machine learning with containers in the first place, right? And if you think about your machine learning environments, so if you're a practitioner, you're working, you're training models, experimenting, prototyping, you might see that all of the environments, especially if you compare your work across a couple of days, weeks, and the environments with your coworkers, maybe other data scientists, machine learning practitioners, that the environments might look very different, right? Everyone is using their preferred machine learning framework, whether it's TensorFlow, whether it's PyTorch, MXNet, Scikit, and also the libraries, right? Libraries change all the time. So not only the frameworks, but also like which version of pandas are you using, which version of maybe matplotlib to visualize, etc. So you have a lot of very specific environment settings, library versions, dependencies on your project. And containers give us the good opportunity to kind of package all of that together in a consistent way. So you're defining your dependencies in the container description, in, for example, the Docker image. You're pulling in exactly the versions you're working with, and the training code you write is tested on. And you package this up, so the training code, the dependency, all of your configurations, and then it's very easy to use that container definition, container image, and to spin it up somewhere else, right? Either you're changing your work environment, whether it's you go from a local laptop maybe to a cloud instance or to an on-premise cluster you might have in your company, or you want to share it with colleagues and they want to reproduce exactly the environment you've been working in. And container give you exactly that flexibility. Then second, why are we thinking and discussing running machine learning on Kubernetes? And there's probably a couple of good reasons. For example, your company might already have standardized on Kubernetes for application development and rollout, or you're looking for a way to really kind of build a machine learning platform, maybe containerized, and you've decided to go with Kubernetes. Many people also call Kubernetes kind of the operating system for containers. And it's basically helping you to run containers at scale. So it tackles a lot of the problems of scheduling and managing your containers. On top of that, Kubernetes gives us a couple of really, really important characteristics, and you see them here. So one is composability. So you can write components and you can reuse them across the different projects, and we will see how that works. The other thing is it gives you portability. So wherever you run Kubernetes, you can migrate your workloads, right? So you can run Kubernetes even on your laptop, although it's very resource intense, but you could. You can run it on an on-premise cluster environment. You can also decide to run it in a cloud or even as a managed service consumed from the cloud. And Kubernetes also manages a lot of the infrastructure tasks, especially when it comes to scaling out the platform and the infrastructure, depending on your workload requirements. So a lot of good reasons why people are looking at running machine learning and their applications on a Kubernetes platform. Having said that, Kubernetes can be a little bit overwhelming. So if you don't have dedicated teams maybe that are doing Kubernetes right now, it might be a little overhead to start Kubernetes just for the sake of running machine learning. And one way to tackle that and really kind of to minimize the maintenance and operations overhead that just comes with running and maintaining Kubernetes, you can think of leveraging a managed service, and there are many offers out there. So for example, within Amazon, we have Amazon EKS, which is the Elastic Kubernetes service, which gives you the possibility to really have a managed Kubernetes control plane. And you really just attach your data plane, meaning everything you're customizing and where you're running your pods ultimately within your dedicated VPCs. It's a native upstream Kubernetes experience, so you can leverage all of the Kubernetes ecosystem goodness, and you can rely on having a platform that is production ready and enterprise ready for your workloads. And also, in case you're leveraging already other AWS services, it also integrates with a lot of those. Another thing, and then we jump right into the Kubeflow project, what also could be of a big help, especially if you have to think of building those containers for your machine learning projects. AWS offers deep learning containers for you to use, which are optimized and customizable environments specifically for your deep learning project. So there are prepackaged container images you can use and then customize to whatever needs you might have. And they are highly optimized in terms of performance and scalability already, and support a lot of different frameworks, whether it's TensorFlow, PyTorch, MXNet. You can do single, multi-node training and inference. So a lot of good things coming around those managed services that might help you do a quick start with your projects on Kubernetes. All right, so I guess as we're in the MLOps summit today, we probably have users which are, I guess, majority ML practitioners and probably also a good amount of MLOps team members. Maybe you even have to do the job as a single person, right? MLOps team member by night and ML engineer or practitioner by day. But really those two have a couple of different needs, and feel free to chime in and comment if you have others, more ideas here or more things you have to focus on. But in general, I think most practitioners would like to have infrastructure abstraction, right? You don't want to think about where to deploy, how to deploy. You just want to really develop your code, share and collaborate with other fellow team members, focus on building end-to-end workflows. That means from the building the model, training the model, testing and tuning, to deploying the model. And obviously, you have some added capabilities which you would like to have, experiment management, maybe you want to leverage services for hyperparameter tuning and optimization. And then on the other side, MLOps team members, they would have to have the task to implement this end-to-end platform for you to run it on. They have to ultimately care about how to abstract the infrastructure and give you this nice environment where you can focus on the core tasks. They probably have to care about the authentication and authorization support of that platform to really make it multi-tenant enterprise ready. And obviously, we all like to train and pull in GPU resources to make the training quicker. But the MLOps team then has to think about how can we manage the resources and also the quota for each and every one using the platform. So there's a lot of tasks involved in really building a platform and then giving you as a practitioner the environment. And I went quickly through the first part because we want to spend the majority of time today talking about Kubeflow. And Kubeflow is a community project that is trying to tackle that problem of giving you an abstraction, in this case, especially on Kubernetes-based platforms, to run your machine learning workflows. So you can think of Kubeflow as the machine learning toolkit for Kubernetes. And Kubeflow is really not just a single product, it's kind of an ecosystem of many, many different open source projects. And all of those projects also address different parts of the pipeline. So part of Kubeflow, for example, is hosted notebooks with Jupyter. You have components for training and for model serving. And I think the one that is gaining a lot of focus right now and a lot of traction and popularity is actually the Kubeflow Pipelines project. And the pipeline is really kind of trying to implement this key use case, helping you as a machine learning practitioner. How can you automate all of those steps? And here's just a sample overview of how a machine learning pipeline could look like in general. So you probably start with data preparation, right? All of your machine learning model training and development needs data. So where do you get the data from, right? Data ingestion. You have to look at the data. Is the data really usable? Is it clean? Are there missing values? Maybe you have to do, and probably have to do, some feature engineering, meaning maybe you're combining specific data sets, or you're combining different elements of your data, different features. Maybe you have to do some one-hot encoding, changing categorical to numerical and vice versa, right? So there's a lot of data preparation and transformation tasks, and an ultimate data validation, and then you can prepare the training data set. And then starts the model training, right? It's the model development and training phase. You train the model, you iterate, you validate how the model is performing, and ultimately you have to train at scale. And at scale means the model gets better the more data you have, right? So it's not enough just running the model training anymore on your laptop. You might need a large cluster, distributed training, maybe even with GPUs, to kind of process all of your data and kind of build this very strong model. And once that is ready and you decide to deploy the model into production, there's a lot of more steps and tasks you have to tackle, right? Model deployment. Do I serve the model 24/7? Is this a real-time endpoint? How do I monitor? How do I detect model drift, etc.? And obviously, you need services and integrations to log and actually keep track of the model performance. So a first project within the Kubeflow ecosystem that is helping you to build those pipelines is actually called Kubeflow Pipelines. And you see here a first screenshot. So Kubeflow Pipelines gives you a user interface to manage and track your experiments, the jobs and the runs. And you can see here on the right a screenshot, and we will see this in a demo in just a bit. You basically develop the individual components, and then you can create this DAG, this direct acyclic graph here, which you might know from other pipeline products. And those individual components are executed in the Kubeflow environment as individual containers on the Kubernetes platform. So it's really an engine for scheduling and creating those multi-step ML workflows. And we'll see how you can do this and get started. You basically can leverage an SDK you can pull into your Jupyter environment and start designing those. So how does a Kubeflow pipeline look like? And here's just the first introduction to understand. So the pipeline consists of different pipeline steps. And you see here just 3 sample components. And a single component is a single step. So for example, a model training step. And each step exists within a container implementation. So for each step, you have to have a Docker image, which is stored, for example, in a container registry. And it also has inputs and outputs, because obviously the component does something. So it receives input data, and in most cases it has an output. And obviously you have metadata that describes the step. And then you can develop those individual components and align them in this graph, in this pipeline. So in other terms, what do you need to do to start building those? So first of all, you probably have some code to execute, right? So you have some Python code, could be a model training code, for example, or a model inference code. And then you would have to have a Docker image. So you build a Docker container image that is using that Python script. And pipelines, Kubeflow pipelines comes with domain-specific language. And using that language with the SDK, you can then use Python decorator functions, which transform this output into a component for Kubeflow pipelines. So this is what you're going to see here. So you're creating and wrapping this Docker container with your code as a pipeline component. And then you would have multiple of those components probably in your pipeline. And you can use another decorator function to create the ultimate pipeline out of those components. And in the last step, you then compile this pipeline to be able to execute it and run it on your Kubernetes cluster. So those are the couple of steps you need to do in order to get started with Kubeflow pipelines. Here's a sample code. So this is how it looks like. So you can see here the pipeline decorator on top, which is the DSL, the domain-specific language that Kubeflow pipelines is using. You give it a name, sample trainer here, for example. You can give it a description. And then you would start building this training pipeline. And you have those individual components in here. And for those components, there are a couple of options. So you can use built-in sample components, or you could also obviously write your custom ones. And then in the last step here, you compile the pipeline. All right, that was a quick theory introduction to the Kubeflow pipelines. And let's actually see this. And I also included the links here to the sample notebooks, which I'm using. So I'm jumping here to my browser environment. And I'm going to jump right away into an environment here. I'm using an AWS environment. And I've installed Kubeflow. And if you're interested in how you can do that, I'll include a link in my presentation, and I can share it here at the end in the Slack channel as well, to a Git repo where we have a lot of sample code that my colleague Chris and I built, which is particularly showing you how you can set up EKS, so the managed EKS Kubernetes service on AWS, and also how to get started and install Kubeflow on top. So there are a couple of Jupyter notebooks that walk you through how to do that. Launch the EKS cluster, do all of the settings, IAM policies, etc. Make sure you have an S3 bucket available, and install Kubeflow. So there's a couple of steps needed, obviously also setting up the roles and policies and credentials. And then you're launching the Kubeflow environment. So as we have limited time here in this session today, I did this as a preparation. And once you've set this up, you will see this Kubeflow dashboard, which I'm in. So this is how Kubeflow looks if you haven't seen it before. And here you see the couple of components. So you have the pipelines project, and you do have the notebook server environment. So here I just started a quick Jupyter notebook instance, which I can use to actually work out of my Jupyter notebooks. And in here, I do have one notebook, and I just quickly show you this one. So this is kind of the hello world of Kubeflow pipelines. So what we do to get started here is, as a first step, we're installing the Kubeflow pipelines SDK. And I zoom in here a little bit so you can maybe read it a little bit better. So this here, KFP, we're pulling in a specific version we've tested the environment with. So this is getting pulled in. You can do a quick check whether you have the domain-specific language available. So this one got installed here. And then we can start building a simple pipeline. So first of all, as I said, we need to have a container image for each component. And here we're doing a very simple example where we're just basically adding a couple of numbers together. So we're calculating a sum. And to do this, we can actually use a very easy, simple Python Docker image. So this is really just a Python version 3.6.8 image. And as you can see here, we're importing KFP, so the Kubeflow pipelines component. We're importing the domain-specific language. And then we start by defining a Python function that is actually describing the interactions, what we want to execute. So in this case, we're adding two numbers, A and B. And you can see here we're returning a container operator, a container op. That's basically the component. The name is calculate sum. We're pulling in a Python image. And then we're executing Python phi, and then we're just running really a code here, which is basically adding up the numbers and then printing that to an output. And we also want to echo that. So here's another step in the pipeline, also returning this container op component. And this one is really just echoing the results of the numbers. All right, so those are our components. And in the next step here, we're defining the pipeline. So here you can see I'm pulling in DSL pipeline, give it a name. And we're doing a calculate sum here. And you can see here the 4-step pipeline. So we're first adding numbers A and B. Then we're adding numbers C and D. And we're also echoing the output. And last step is compile the pipeline. So this is what we're doing here. And once it's compiled, we can then call the run pipeline, give it a name. And with that, we can check back here in our environment. So I'm open up here this link, and it takes me to the Kubeflow pipelines environment. You can see I'm in experiments here. And here you can see the runs I've executed. So this one is the calculate sum pipeline. And here you can see the different components. So the first one here, if I go to the inputs outputs, was adding A and B, and we have the output is 17. And we can see the second component here, which is doing another sum, output 11. And then we have the third component, which is adding up those. And the last echo component is the only one that is actually logging something. So if I click here and I click on the logs, you see the echo that we defined in the notebook before. All right, so this is a very, very simple hello world of Kubeflow pipelines. I said that I also have summer integrations here. And for those of you who are familiar maybe with Amazon services, and especially the Amazon SageMaker platform, this is AWS's managed machine learning platform. You can also scale those environments so to use not only the built-in components, but also use Kubeflow, but maybe run the model training on the cloud, Amazon SageMaker. And here's another example that shows you how you can actually do this. So in this example here, we built an MNIST classifier pipeline using Kubeflow and SageMaker. So the advantage is you can stay within your Kubeflow environment and just pull in a couple of those operators to integrate with AWS. And here we're using an MNIST example. We're installing a couple of SDKs specifically to interact with AWS. So this is the AWS Python SDK, Bodo. We're also installing the Kubeflow Pipelines SDK. And I scroll down here. We need to set a couple of things. So we need to set our account IDs, obviously, and the SageMaker, a 3-bucket, for example, we're going to use, and make sure we have data available in F3. And then we can start building the pipeline. And I'm importing here a couple of components from KFP, the components, the DSL, etc. And we do have custom integrations for AWS as part of Kubeflow pipeline, so we can pull in here, for example, use an AWS secret. And the good thing is AWS has spent time to develop specific Kubeflow pipeline components to integrate with SageMaker. So here we're using the integration to train on SageMaker, to create a model, to deploy a model, and also to do a batch transformation. So we're pulling in those components, and you can see the YAML files here. And then we can use those to create a pipeline. And here we're using ECR images. So those are the container Docker images for a built-in k-means algorithm from SageMaker. So you have the image locations here, and you can start building the pipeline now. So here you can see we're setting up a couple of parameters, the region we're operating, our images we're going to use. And again, we're using the pipeline definition, calling this an MNIST classification pipeline. And we're passing in information which region to execute, where our container image lives, the S3 path. And we can now also define instance types. So on which AWS instances do I want to execute? And here I'm just picking an instance type C4X large. I'm going to say I'm going to run this across 2 instances. I'm going to do a distributed training run, for example, and outputs, passing in a role that has permissions. And here you can see how I'm building custom components now. So here I'm using, for example, the SageMaker training op, passing in the information, and also defining where to store the model output. And I'm doing a create model step next. So I'm building the model once I've trained it. I'm going to deploy the model with the next component. And then I'm also doing a batch transformation, which is doing a batch inference on my input data. And the last step here, I'm compiling my pipeline. And again, I'm executing the pipeline. If you're interested in the YAML that is actually created in the background, have a look here. So it's getting pretty long YAML files here. And we're deploying the pipeline. And now the nice thing is, once you've executed this, and I just have to quickly relog into my account here, those components actually executed in the AWS environment that I specified. So I'm just going to show you here quickly before we wrap. This is my AWS console. And in here I go to SageMaker, which is the platform we've integrated with. And if I click here on training jobs, you can see that here is the training job that I started from my Kubeflow pipeline, and this one has executed on the AWS cloud platform. And one advantage here is you get only billed for the time the training jobs are running. You could even use spot instances to even save more time and money. So here you see all the details, the settings, and here you see the instance types we specified. Perfect. And this is really how you can integrate Kubeflow pipelines with, for example, a managed service to scale your environment even further and use those services. And here you see the model endpoint that also got deployed. All right, so in the Kubeflow pipeline, just a quick wrap up here. Here's the definition of the pipeline, which I showed you from the Jupyter Notebook. And all those components, as I showed you, executed on AWS Cloud Platform. And this way you can leverage all the goodness of the managed services, whether it's the model training, whether it's the model hosting, deployment. Also, if you're interested in labeling data, there's a service part of SageMaker called Ground Truth, which you could also integrate. So a lot of good things on how you can even scale your Kubeflow environment further and integrate with other services. So let me quickly jump back to my presentation. And I have a couple of more slides here, and I guess the slides will be shared afterwards that go in a little bit more detail here in how you can integrate with the services, and also the different components and operators we have for Kubeflow pipelines and also for Kubernetes. This is how we just built the pipeline, and we branched out to run the components on SageMaker. This is the demo I showed. And just to wrap up, Kubeflow plus Amazon SageMaker really can deliver a lot of value. So for one hand, you have the Kubeflow project, which is running on Kubernetes, which gives you the portability, composability, scalability, and all the other goodness of running workloads on Kubernetes. And on the other hand, you can integrate with cloud managed services, which can give you even further capabilities, whether it's a fully managed infrastructure, automatic model tuning. You can leverage spot training, which comes up to 90% savings in cost for those instances. You have scalable inference endpoints and a lot of capabilities around model monitoring as well. So this was a quick run-through introduction to how to get started building Kubeflow pipelines and also integrate with cloud managed services. And if you want to get started, I've put in here a couple of links: Kubeflow on AWS, which is part of the Kubeflow documentation. And if you're interested in the integrations in particular, have a look at the components for Kubeflow pipelines. And we also do have a blog post that is particularly touching on the latest contributions on how to leverage enterprise-ready Kubeflow and how AWS integrates security and scalability into those machine learning pipelines. And last but not least, if you're interested in getting more hands-on experience, Chris and I are running monthly workshops on particular that topic. So we're running not only data science on AWS, but also have a dedicated section on how to get started with Kubeflow and showing those notebooks and a lot more. And the next date is actually next week, Saturday. So if you're interested, feel free to follow the links and join us for a full day of hands-on. And with that, thank you very much for joining the session. And I think we have quick time for a couple of questions, and otherwise I'm happy to answer those in the Slack channel. Thank you very much. And back to you, David. Do we have any questions? And I'm not sure, I cannot hear you, David, if it's me or if you're on mute.
Oh, sorry, I was on
There
mute.
you go, yeah.
Okay, thank you for the excellent demo, and the links will be posted on Slack. So we have a couple of questions for you, Angie. And thanks, guys, for voting up the top few questions. We try to cover as many as possible. So for the first question from Period, he's asking Ajay, are there any links between the Kubeflow and Airflow projects?
So it's really coming, yeah, it's a popular question, right? Airflow, and there are a lot of flow projects around. So Airflow has been around for a little bit longer, coming from Airbnb. Kubeflow started as a project later, in particular in the focus of porting the cloud native projects, and in particular everything related to machine learning to Kubernetes. Airflow has been around, as I said, a little bit longer. Is pretty popular as well. So it really depends on which tool set you feel is targeting your use case better, I guess. If you're fully into the cloud native ecosystem, you might want to start with Kubeflow. If you're not necessarily running on Kubernetes, you can look at Airflow to orchestrate. And also, I think Airflow has some executors to actually execute on Kubernetes. So there's always, many tools for the same job. And yeah, kind of really depends on which you feel more comfortable, I guess, working with, and how your environment looks like, I guess.
Thank you, Angie. So second question from Sliza. Hi, Angie. Why would I use SageMaker if Kubeflow training can scale as well? So what are the benefits of SageMaker?
Yes, and I try to tackle a couple of those, but really it's Kubeflow is just graduated basically to the 1.0 releases, and the community is doing a tremendous job in building up the capabilities. But let's say you already have maybe parts of your data in AWS, for example, or you want to leverage some additional service capabilities. As I said, maybe data labeling jobs. And also remember that part of your machine learning pipeline is more than just the model training, right? I showed in the beginning that those pipelines consist of many steps, and maybe you want to have another pipeline that is helping you with the data transformation steps in the beginning, right? So you could have part of it running maybe outside of Kubeflow in an environment which you can automate, do data labeling maybe with ground truth as a service, or you want to run some Spark jobs, for example, on on the Amazon AWS EMR environment. So there's a couple of things that just, you can have more options and to include more steps maybe into your overall machine learning pipeline services. And then maybe you want to just spawn up, the machine learning workloads outside of your Kubernetes environment. Maybe you have constrained resources in the Kubernetes environment because other teams are using it. Maybe application development is using it. And you want to more have like a fully managed infrastructure to just scale out, right? So you could use SageMaker training jobs to also leverage GPU instances. And the nice thing, what I said is it's built by the second, so you're only paying for the seconds. The instance is executing, for example, a training job. You can leverage capabilities like spot instances, which are coming at a high discount, which you can also use to optimize the overall cost of running distributed training. So there are a lot of like specifics how to optimize and also add capabilities to what Kubeflow offers as of today. But you can stay also within your Kubeflow environment, leveraging those component integrations to kind of, spawn those tasks and run them in the cloud environment and keep working the rest prototyping and developing within the Kubeflow notebooks.
Brilliant, thank you. So we probably have just time for 2 more questions. Is that all right? So Angie, a question from Zalihat. Hi, do you have any roadmap for MLOps? And do you need to be good with machine learning before you get into MLOps?
Yes, I mean, it's probably kind of different disciplines, right? So depending whether you have to do both jobs as a single person, if you're just, a small team, many of us probably tackle a couple of those aspects as part of the day job. But normally the MLOps people are more focused on, as I said, providing the infrastructure platform services, making sure everything works, is if needed multi-tenant and secured, etc. Whereas the practitioner is really more focused probably on developing the model code, developing the models, comparing the models. So so for training, I guess it's really more coming to your specific implementation needs. There are a couple of good resources, I guess, out there, whether it's a couple of books on the topics or thanks to so many events running online, good online sessions from different meetups. AI Camp probably has a couple of sessions as well. So I would just suggest maybe look where you think you want to learn something new or add some knowledge, and then look for offerings. Normally, as I said, in a perfect world, I guess it's more like 2 different roles, but obviously everyone is doing a little bit of everything nowadays. So so I guess a good understanding, and also just to have understanding of complexity, what's needed to run those pipelines. It always helps to understand what each team has to tackle.
All right, thank you. And just one last question from Oscar. So, hi Angie, Kubeflow supports model the question should be, does Kubeflow support model ML registry data and data version control to track all artifacts used within the ML lifecycle?
Yeah, so there's a couple of projects. There's actually experiments and metadata tracking in Kubeflow starting. So it's not yet, let's say, maybe tackling all of the different aspects. So especially, I think data versioning is not part yet of it. But you can definitely create experiments and save some information. So as it's community project, also like for the follow-up question on the roadmap, Kubeflow is all open source, so feel free to go on the community side, kubeflow.org, and there's a lot of information, Git pull requests and roadmap shared, what's been worked on. And yeah, those projects are in heavy development right now. So check it out. You can play around with the environment. It's starting to be integrated, and it's definitely an important part to be able to track experiments. And also the data versioning part is definitely a big ask from a lot of people in the industry. And yeah, it's in the beginning in Kubeflow, and hopefully, yeah, evolving.
All right, thank you, Angie, for the talk and also answering the questions. There are quite a bit more, though we're a bit short of time at the moment.